Good afternoon, everyone. Thank you for being with us in person. Thank you for those watching us online. This is the third anticipatory briefing. We're going to talk about the future of archaeology. So anticipatory briefings are interactive series of academic-led talks that bring topics from the GESDA Breakthrough Radar, which you've all picked up in your bags at the welcome desk. And basically, we bring to life the latest science, and we try to explain, we ask our speakers to explain what impact we can expect in the next 5, 10, and 25 years. The format is a 15-minute talk followed by a 15-minute Q&A. Our speaker today is a professor of classical archaeology at the University of Lausanne. He's the director of the Swiss School of Archaeology in Greece. He was the A.W. Mellon professor at the American School of Classical Studies at Athens, which is the oldest and largest US overseas research center. He has conducted extensive archaeological research in Greece, mainly in a place whose name I have a very hard time saying because it's Euboea. E-U-B-O-E-A. Maybe he'll tell us how we say that. He also worked in Attica and Argos. With him, we're going to learn how innovation like the analysis of ancient DNA or the virtual preservation of World Heritage sites will redefine our understanding of historical narratives over the next 5, 10, and 25 years. Please help me welcome Professor Sylvain Fachard.
Thank you very much. It's a pleasure to be here, and I would really like to thank GESDA and the entire team of the Radar for making this happen. It's a great initiative, and I'm really happy to be here. I'm alone speaking. I just want to set up a few things. First of all, I was trained in social science, history, and archaeology. I'm going to talk about ancient DNA. I'm going to talk about proteomics. I'm going to talk about technology. In order to do that, I've been collaborating and working with scientists in this top fields. So I'll try to answer all your questions, but behind there's a big team, and I think it's only fair to mention them, and you have the full names that participate in the Radar in the book. Archaeology, really. How is the search of the past compatible with GESDA's use of the future to build the present? You're thinking it's 6 p.m. I came here probably to learn about neuroscience or quantum technology, and here's a talk on archaeology. How can archaeology, in fact, contribute to finding global solutions for a sustainable future, which is at the core of GESDA's vision and mission? Obviously, archaeology will not save lives. It will not save the planet. But many scientific disciplines don't do that, and still, they contribute to a more diverse, equitable, interesting, logical, thoughtful world. Today, archaeology is being revolutionized by several breakthroughs in science and technology. These breakthroughs help us formulate new questions and insights regarding the complex societies and human realities that preceded us for thousands of years, thus reshaping some of the questions and issues we face in the present and the future. Long-term human resilience, climate change, disease, history of migration, and the preservation of world heritage. Yet, these breakthroughs also come with a sense of urgency. War, deforestation, urban expansion, global warming, and widespread destruction threaten world heritage on a daily basis, as well as archaeological evidence, to unprecedented levels, thus forever erasing signs of past human activity. But what is the past? And how do we study it? I always quote, I love this quote from the historian David Lowenthal: "The past is a foreign country where we all come from." The past obviously has always fascinated human beings. The discovery of older artifacts by past societies was always a matter of marvel, questioning, and interpretation, often biased and wrong for lack of knowledge. And this is when archaeologies enter the picture. Archaeology is a set of methods whose goal is to use material remains to create a discourse, logos, about the past. And the methods and discourses in archaeology have changed a lot. The first archaeologists were mainly aristocrats with no or little training, relying on their private wealth, and were eager to discover and study prestigious artifacts and monuments. Archaeology's beginnings and the first excavations stem from large-scale projects in countries such as Greece, Turkey, and Egypt, mostly by colonial powers. And these countries lacked state legislation and political autonomy. And then science came. And hopefully things changed, mostly following World War II. Carbon-14 dating, dendrochronology, opened great avenues and perspectives for chronology and the study of climate and past atmospheric conditions. And you can see on this picture Libby, who won the Nobel Prize in 1960 for his contribution to archaeology and age determination in sciences. Archaeology became regulated and subject to law. Archaeology became a scientific discipline taught in university departments worldwide, with journals, methodological debates and advances, and scientific-based approaches. Now, these developments greatly impacted the discipline, making it more data and science-driven, more precise, and more reliable. In recent years, advances in science and technology have continued to reshape archaeology, with new techniques significantly enhancing both practice and knowledge, thus obtaining increasingly detailed information about human origins, migration, and diets. And I'm going to give you 3 main examples. First, the big DNA revolution in archaeology. Genetic material obtained from ancient decayed bones has yielded near-complete genome sequences. In 2010, an entire Neanderthal genome was mapped for the first time, making the groundbreaking discovery that modern Homo sapiens actually held 2% of DNA in common with extinct Neanderthals. In the last decade, scientists have sequenced the genomes of more than 10,000 ancient individuals. Ancient DNA has revealed family relationships, kinship patterns, and migrations. Paleoproteomics, which is a large-scale study of proteins, enables now data to be extracted from fragmentary remains, shedding new light on past diseases and diets. Analysis of pathogens reveal the disease and epidemics suffered by past societies. Proteomics, for example, was used to study Ötzi, you probably heard about him, the ice man, stomach a few years when he was discovered, and we're able to find what he was eating. We have his entire Last Supper. Scientific advances also are improving paleoclimatic studies, allowing links between climatic events and societal disruptions, and potentially giving insights into the adaptability and resilience of ancient human populations. Now, we all know this curve, and we all know that we're standing on this red seat on top of it right now. We know less about the methods that are used to produce such curves, and we can now mention pollen analysis from lake sediments, cave deposits in speleothems studying the stalactites and the stalagmites to create a curve of pluviometry in the long term. We obviously use coring in glacier for ice and the North Poles. We use it for coral, and we can also have marine sediments. And all these techniques help us recreate a curve of pluviometry and temperature evolution in the very long term. 3D laser advances also are exposing and decoding world heritage. And this is my third point, with unprecedented clarity, providing new insights into the history of buildings, architecture, ancient technology, and the details of cultural achievement. 3D laser scanning that you can see here allows us to gain a huge amount of time when doing field work. We have now a precision of under the centimeter using this technique for ancient buildings, and it's getting cheaper and quicker every year. We're now using LiDAR, remote sensing, which is light detection and ranging, to locate in entire areas of the Earth, including the Amazonian rainforest, to explore from the sky without even sending people on the ground, to locate ancient sites and monuments, as well as, unfortunately, illegal excavations and looting. So where are we heading? Let me outline now, in the remaining part of this talk, the big questions and issues in ancient DNA studies, paleoclimate, and world heritage studies, and mention the future developments we expect in these fields in the next 5, 10, and 25 years, which I think will transform archaeology. 5 years. In the next 5 years, we can expect more comprehensive reconstructions of the lifestyles of past human populations, including family trees and population trends. New and improved paleoclimate proxies should enable us the sampling of a larger range of past conditions. Cheaper and more accessible sampling techniques will facilitate the expansion of paleoclimate studies to previously understudied regions, such as Central Asia and South America. Technology will enable digitalization and knowledge sharing thanks to rapid and accurate 3D modeling of artifacts, buildings, and even landscapes. Cheaper and more accessible techniques will also facilitate our architectural modeling to record monuments, especially in sensible and unstable regions of the world. And I will come back to this point in my conclusions. 10 years. DNA discoveries will facilitate population size estimates and interpersonal interactions in past societies, including migrations. We could probably also hope to hit 100,000 ancient genomes reconstructed. Global biobanks for human biological data will enable improved access and facilitate analysis. New light on past diseases, pathologies, and diets, and their impact on past societies could actually prepare us for future pandemics. Environmental DNA from sediments and other sources will be routinely used to reconstruct past ecosystems. Researchers will reconstruct past food webs using a combination of proteomics, tooth wear, and other methods. Researchers will probably achieve standardized methods for assessing paleoclimate proxies, enabling reliable and systematic climatic reconstructions. High-resolution LiDAR, probably down to 1 centimeter, will improve aerial analysis of monuments in the planet's most remote areas. Photogrammetry 3D models will also be produced remotely, allowing us to preserve ancient monuments from violent destruction and allow us to monitor and possibly restore them based on these models. Also, we can imagine to train AI in ancient languages in order to record and even complete missing texts. 25 years. Researchers construct a global history of human diseases from the origins to the present. Ancient DNA analysis becomes standard practice in funerary archaeology, thus recreating individual and societal patterns of mobility and social change, resulting in new history of global migration spanning thousands of years. Drivers of past extinctions are brought to light. High-resolution ecological models are applied to reconstruct past ecosystems. The impacts of climate change on human history are clarified. Research achieves high-resolution global paleoclimate records for the entire span of human evolution, probably 7 million years ago to the present. This enables detailed reconstruction of the many impacts of climatic change on human evolution in history. Scanning improvements give new views of artifacts. 3D scans probably extend beyond the visible spectrum, including data on the composition of pigments on surfaces and materials in the soil. We can probably imagine remote monitoring of cultural heritage, immediate responses in case of war and destruction, a world bank of architectural models of protected sites to reconstruct them in case of destruction. Outlook. I love this quote from Winston Churchill. The farther back you look, the further ahead you can see. Now, we can see much farther back and more clearly than we once could. And soon, we will be able to see farther and more clearly still. Today, I hope to have shown that science's contribution to archaeology and the study of past human societies is incommensurable. For the first time, we were able to ask questions and issues that past archaeologists only dreamed of 25 years ago. And this, in fact, changes the way we write history, how we see it, and how we use the past to confront the future problems and issues. And I'm going to follow here three main perspectives. First, understanding the resilience of past societies may offer insight into our own climate-threatened future. Second, new light on past diseases, pathologies, and diets, and their impact on past societies could prepare us for future pandemics. The enlargement of genetic libraries will allow us to rewrite the story of human migration around the globe, including the genetic composition of past and present ethnic groups and states. An increased fact-driven understanding of past migrations and of the genetic identity of ethnic groups will modify the basis of current and, I think, future geopolitical and nationalist debates for the better, based on facts. Yet, the seemingly bright future is darkened by several threats, which I mentioned before: the continuous destruction of sites, graves, skeletons, and artifacts. All these destructions endanger the diversity and richness of world heritage and history. Once they're gone forever. Conflicts worldwide continue to target undocumented archaeological sites. We can think about Palmyra a few years ago, the bombing of the Buddhas in Bamyan by the Taliban, and so on. And some studies show that in 25 years, entire areas of the world, including Europe, will be stripped of unstudied archaeological artifacts and sites. There's an urgent need to record world heritage using technology and to gather paleoclimatic data as rapidly and widely as possible, because contemporary climate change is erasing critical evidence in the cryosphere, mainly in poles and glaciers. Now, let me end this talk with a personal story and a personal picture. This summer, I was in the Alps with students conducting archaeological field survey on glaciers at an altitude of over 3,000 meters. The melting glaciers, at a dramatic speed, are spitting out hundreds, if not thousands, of past human artifacts, some of them over 2,000 years old. Now, without proper scientific documentation in the next 10 years and dating, they will disintegrate and disappear, thus forever destroying historical evidence on past human occupation in the Alps and all the stories that go with them, patterns of mobility and migration. Now, science contributed to the development and the establishment of archaeology as a scientific discipline. It can now, I think, contribute to saving world heritage and our common human history. Thank you.
Thank you very much, Sylvain. It's now time for questions. Do we have someone who wants to ask the first question, or do I get this honor? Raise your hand, and we're going to give you a microphone. I'll start. While I was listening to you, I really was wondering why this matters. I think it's a question you get all the time. And at the end of the talk, you started to answer that a lot. You said, we want to learn from the resilience of past societies, maybe how they address climate change or pandemics. You also talked about the geopolitical debate, which unfortunately is not really rooted in science and facts these days. And you also, I really like this idea of you're basically recording monuments. All these things, studying past lifestyles, past climate, recording monuments. Can you tell us very concrete impact that we can see in our daily life for all these three things?
Yeah, as I said before, archaeology will not save lives, neither the planet. That's a fact. I think that knowing the past in a better way with facts and bringing all these, this evidence together actually helps us in a few things. First of all, still the climatic curves we have are still difficult to match with societal disruptors, for example, because the chronology is not right yet. In the Mediterranean, we have a massive drought, for example, around 2000, and then this corresponds to the collapse of palatial societies in the Mediterranean. Now, scholars think that they might be linked linked to climate, the societal disruption, but we're not sure. In the next few years, I think we'll be able to match that curves in terms of chronology. And then, once we have that, we can really study the disappearance and the evolution of past societies with a direct impact of climate. And this actually can provide some solutions in some countries of the Mediterranean and other parts of the world to see how past societies dealt with these climatic changes because they always existed.
So last year at this very room, we had a session about psychedelics, for example, and it seems that we're kind of rediscovering some of the substances that humanity have been using for thousands of years. So is it why it matters? For example, it could be something that you would find in the stomach of a 6,000 years old body that has been recovered on a glacier?
This is fascinating. For a long time, archaeology never dealt with personal stories. The skeletons we have, the people we excavate are individuals. We give them numbers and letters, A, B, C, 1, 2, 3. Now, more and more, thanks to DNA, we can really enter and bring their personal stories, personal ties in the community in a much different way. And this, I think, changes the way we write history and we see it. By studying diets too and habits linked to agriculture, to climate, it changes the whole perspective. And we can really use these technologies to answer these questions. Proteomics, the study of proteins on tools, in houses, in boxes, in everything we can excavate now is really changing the picture. And the study also of past pandemics and diseases can actually, help us in the future. And there's an incredible article that came out 2 years ago by Sylvain, who got the Nobel Prize, as you know, 2 years ago for his advances in ancient DNA. Well, in this article, he shows that actually people who have a higher percentage of common Neanderthal DNA, 3%, 4%, which is higher than the average of 2%, actually had more chances to get COVID-19 a few years ago. So these examples show that perhaps we can anticipate some of the pandemics in the future.
It's interesting because there's this relationship between the past, the present, and the future. And you mentioned, for example, that the future, the past can educate us about the future. A good example is food. It's like now we're labeling food without chemicals, bio food. But it's kind of food from the past, right? So we're going towards eating the way we would eat 100 years ago, and now it's more expensive. Like we have to pay for someone to put that little sticker on it. So that's the kind of things that we can learn again, and it seems that we have lost. And I think it's interesting. Like right now, there seems to be a movement towards more traditional, more ways of eating, of managing your health, etc. So rediscovering this is interesting, and let's talk a little bit about this idea of recording monuments.
Yeah.
Like, can you be very concrete about the use of that?
There's obviously we're documenting. We try to document all these past monuments. It's part of our heritage, art history. There's also a lot of tourism involved. People go and visit these monuments, and these monuments are very fragile. And the fire of Notre Dame a few years ago just proves it again. The whole roof burned down, and we didn't have a precise model of the timber and the roofing system. So monuments disappear. They're well monitored in Northern Europe. Other parts of the world, they're not monitored at all. We can think about Syria. We can think about other dramatic examples that I mentioned before. Now, technology, I think, can really help us to preserve this heritage because as we go on, they're disappearing on a dramatic basis. And losing this technology, losing this knowledge in ancient architecture is really very sad. An example, a few years ago, chemical analysis of the mortar used in the Pantheon in Rome, people were amazed by the quality of the concrete. And the Romans had this technology that was lost afterwards. They were able to use this volcanic ash to create this amazing cement that could actually reconstruct itself automatically with the contact of water. And these are old technological tools that are lost. We can lose more, and it's just important to document them for the future.
There's some interesting cross-selling among, like with video games, for example. I think when Notre Dame burnt, like there was the Assassin's Creed franchise from Ubisoft, who had kind of modeled and it was used. So
I actually looked into that because it was very intriguing, but the model was not good enough.
It was not good enough.
It was not good enough to recreate the timber.
But it's
an interesting example.
It seems that culture and typically video games and movies are a great way to interest people in the past.
Yeah.
And so they could pay the bills of you going with a LiDAR and the laser. We have a first question here.
Yes. If I got right what I have heard on seen, even with films, since the day of my birth, there are two limitations to our understanding and knowledge of the past. One is lack of evidence, and you showed us how the progress of techniques could, for instance, change our view of the relation between Neanderthal and our supposed ancestors. Another one maybe deals more with history than prehistory, is the kind of question we ask. You know better than I do, Paul Venn, les Grecs croyaient-ils à leur mythe? The mere fact of asking the question challenges, I don't know how much it challenges professionals, but still today you have people with PhD in archaeology delivering speeches on ancient Greece, which does not take into account the denial of Paul Venn. When I went to school, the textbooks were taking at face value all the Greek myths. Tourist guides, even with PhD, still stick to that. So how do you see the relation between the technological breakthrough, which entitle both the best and the most mediocre archaeologists to bring new answers, and the question which culture, reflection of people like you, but it needs more than just DNA, can ask to challenge biased views?
Thank you for your question with many details. I will not tackle every single detail that you mentioned, but as I said in my introduction, archaeology is a discipline that is not taught in universities. I think that archaeology has to look and follow science. This was the solution, especially after World War II. And I think that archaeology, the future of archaeology, is driven by science. Obviously, we're not trained in science, we're trained in social studies, and that creates a dichotomy, that creates a problem in formation. So I think that what archaeologists have to do is to come to GESDA, but follow you guys, basically, and collaborate with scientists all around the world in order to absorb this technology, this science, to ask new questions and old questions as well. And this is what we try to do when we train our students. Now, we will not resolve some of the big esoteric or religious issues that you mentioned, but still, by studying sanctuaries, using proteins, studying animal sacrifice, using technology, we're actually reframing many debates in a positive and fact-driven way.
I think it's not just archaeologists. Don't worry too much. Not just your community. A lot of the world of business has a very hard time also going towards science. It's not only archaeologists. There's many. It's a widespread issue. We have time for one last question. We have 1 minute and 21 seconds on the clock.
Thanks a lot. I'll try to be quick. I would have a question with regards to ancient DNA in marine sediments, and especially deep sea sediments. So you mentioned that it could be used in the future to unravel also past biodiversity in basically our oceans. So the deep sea is cold to degrees, so a lot of biodiversity could be conserved. So my question would be, what is ancient in this case?
I didn't understand the second part. You said with the oceans?
So the deep sea sediments, they are cold 2 degrees Celsius. And you referred to ancient DNA studies in sediments. And my question would be, how long can you go back in time?
It depends how deep we can core in many examples.
That's not the limit.
No, but for example, in deep sea coring is interesting for pollen analysis because at a macro scale, we can do coring in archaeological sites to get an idea of what's going on the site. but deep sea coring in bays, for example, give us a bigger picture thanks to all the pollen that is blown with the wind and just deposit in the sea. So if you can core, 10 meters, 20 meters, obviously in the sea depth, then you can get more information. I'm not aware of how many thousands of years you can go back. It really depends on every situation. But we are hoping in the next 25 years, and my colleagues, that's what they tell me, that we can hope to recreate some climatic curves going back millions of years.
Thank you very much. Our next anticipatory briefing is going to be tomorrow morning, 11 a.m., food systems. And for now, time for a big round of applause for our speaker, Sylvain Fachard.
Thank you.